All right, here we go with our 2-1 practice worksheet number 2, video key. In this video, I'm going to be going through each of these examples and showing you how to do each of them in depth. If you complete this on your own, you can go back and check your work for each of the problems that you may have questions for. Or if you're following along with me, I recommend that you pause the video before I start each problem, try it on your own, and then check your work. Okay? All right, let's jump right in. So this worksheet practices slope-intercept form. Slope-intercept form is y equals mx plus b. For this whole worksheet, we're going to be using y equals mx plus b, where m is our slope and b is our y-intercept. Now, slope is exactly how we've learned in the past: rise over run, change in y over change in x, y minus y1 over x2 minus x1, all those different ways that we're going to represent slope. The y-intercept is where the graph crosses the y-axis. Let's go ahead and write the equation in slope-intercept form that has a slope of 1/3 and a y-intercept of 2. So we want to write this equation in slope-intercept form. That's y equals mx plus b. We already have our slope and we already have our y-intercept. So we can just plug these both in for y equals mx plus b. Our slope, 1/3, is going to be our m. Our y-intercept, 2, is going to be b. So plugging that into y equals mx plus b, we have y equals 1/3 x plus 2. And that's our answer. This is in slope-intercept form. Number 2, we have a slope of 3 and a y-intercept of -4. Again, we have our slope and our y-intercept. So our slope is m. So in this case, m equals 3. And our y-intercept, -4, that's going to be b in slope-intercept form. So we have both m and b, so we can plug that into y equals mx plus b. We have y equals 3x plus -4. Now we can clean this up. We've got a plus and negative. If you got to here, I'm happy with that. If you want to clean this up a little bit and say y equals 3x minus 4, then that works as well. All right. Let's move on to numbers 3 and 4. Here we have equations in standard form, and we want to convert them into slope-intercept form. So again, slope-intercept form, y equals mx plus b. You might notice that in slope-intercept form, we have y by itself. So it's sufficient for us to solve for y in each of these equations. So number 3, how do we solve for y? We want to get y by itself. In order to solve, we're going to use reverse PEMDAS. So we start with the addition and subtraction, and then we deal with the multiplication and division. In this equation, I see we have addition. So I'm going to deal with that addition first. Well, what's being added to my y term? We've got a -2x. So to undo that -2x or minus 2x, we are going to add 2x to both sides. On the left-hand side, our -2 and plus 2x cancel. And on the right-hand side, we have 7 plus 2x. Those are not like terms. We cannot combine these. Therefore, we can just leave it as 7 plus 2x. Bring down the equal sign, and all that's left on the left-hand side is y. So we got y by itself. This looks really good. We have y equals 7 plus 2x. If you made it here, I'm happy with that. But we can again clean this up and make it a little bit more like slope-intercept form by rearranging these terms. This 7 and 2x can be flipped around, so we have y equals 2x plus 7. I'll accept either of these answers. All right, number 4, again, we want to solve for y, so I'm going to use reverse PEMDAS, deal with that addition and subtraction first, and then take care of that multiplication and division. So we have to see in our equation, do we have any addition or subtraction? Yes, I see we've got subtraction. Well, what's being added or subtracted to our y term? I see that this 3x is being added or subtracted. Well, this 3x here, this is a positive 3x. So I like to go ahead and just write in plus 3x or positive 3x. So in order to undo a plus 3x, we're going to do the inverse operation. We're going to subtract 3x from both sides of the equation. On the left-hand side, they cancel. On the right-hand side, we have 24 minus 3x. Well, again, those are not like terms, so we cannot combine them. So we have just 24 minus 3x. On the left-hand side, all that's left over is our minus 4y or negative 4y. We've got one more step to get y by itself. We have negative 4 times y. So in order to undo multiplication, we are going to divide by negative 4. On the left-hand side, it cancels, and we're just left with y. On the right-hand side, we have to divide out each of these terms by negative 4. So 24 divided by negative 4 gives us negative 6. And then negative 3 divided by negative 4. Well, we can't divide 4 into 3, so we can just deal with the signs here. We have a negative over a negative. Well, negative divided by a negative is a positive. So we can say that that's plus 3/4, and then don't forget that x. We want to bring down the x. If you made it here, I'm really happy with that. Let's just make it look more like y equals mx plus b, our slope-intercept form. So you can flip around these two terms and get y equals 3/4 x plus negative 6, or you could clean that up further and say just minus 6. And we get that answer here. We got two more. We've got graphing these lines in slope-intercept form. So get out your straight edge. We're going to graph these lines. Y equals 3/5 x minus 6. So the first thing that we have to do is identify the slope and the y-intercept. Well, if this is in slope-intercept form, y equals mx plus b, m is our slope. That's that number in front of x. Our slope in this case is the number in front of x, 3/5. Our y-intercept is that number tacked on at the end. So in this case, we have minus 6, so our y-intercept is negative 6. As an ordered pair, we have the coordinates 0, negative 6. And I like to write my y-intercept as an ordered pair. To graph this line, we first plot our y-intercept. So on our y-axis, we count down 6. 1, 2, 3, 4, 5, 6. And we plot the y-intercept. From there, we get our second point by using our slope. So our slope is 3/5. Well, slope is rise over run. That tells us rise 3, run 5, or up 3 and right 5. So from our y-intercept, we're going to go up 3, 1, 2, 3, and right 5, 1, 2, 3, 4, 5. So from our y-intercept, we go up 3, right 5, and that's how we find our second point. Go ahead and use your straight edge and ID the side of your calculator case and connect the dots, and you got a line. Make sure you extend your line all the way across the grid and have arrowheads on both sides. All right, let's go ahead and graph number 6. Here we have y equals negative 2x plus 8. Now, again, the first thing that we have to do is identify the slope and the y-intercept. So the slope in this case is the number in front of x. The number in front of x is negative 2. The y-intercept is the number tacked on at the end, the one that doesn't have an x. So we have plus 8 right here. So our y-intercept is positive 8. As an ordered pair, we have 0, 8. Now, in order to graph this, again, we start with the y-intercept, so 0, 8. We're going to count up 8 on the y-axis. Our slope is negative 2, rise over run, But in order to use that, I like to put this in a fraction form. So remember, any whole number that we have, we can always put it over 1. So our slope of -2 can be rewritten as -2 over 1. That works for any whole number. So now we have rise over run. From our y-intercept, we can go down 2 and right 1. So I'm going to go down 2, right 1, and you can keep going. Plot a few points. Down 2, right 1, and just keep going. You can plot as many as you can fit. Use your straight edge to connect the dots, and you got a line. Don't forget to extend your line all the way through the grid and to draw arrowheads on both ends. All right. So this has been the video key for the 2-1 practice worksheet number 2. We'll see you tomorrow in class. Bye, everyone.